AI Realized, the podcast about everything that is new, now, and next for enterprise executives deploying AI. Hosted by myself, Christina Elwood, and my collaborator, David Yakubovich.
Our guests will share what's driving AI adoption, use cases, and business models for the data and AI economy.
Why the future is bright.
Welcome to AI Realized, the podcast for enterprise executives leading AI deployments. From tackling security, data, and operational challenges to navigating organizational transformation, AI deployment offers a unique opportunity to redesign our organizations from the inside out. I'm Christina Elwood, your host for today's episode, and today we're talking with Jason Williamson, the CEO of MythWorks. In this episode, we're going to stretch how we think about intelligence itself. Instead of talking about bigger models and more GPUs, we're asking a different question. How much real intelligence can you get per watt per dollar? And in places where work actually happens, like at the edge in factories, vehicles, and devices. Jason leads an AI company building models that deliver serious reasoning power on a much smaller, more efficient footprint. And he brings a rare mix of perspectives, having led startup and ecosystem programs at AWS and Oracle, and from his experience teaching data science at the University of Virginia. His work as a venture partner at the Tebow Group and his work on ethical AI applications to combat human trafficking. In this conversation, we're going to get into three big topics: what it really means to build a model that mimics human cognition, why the current GPU-heavy AI industry is unsustainable, and what it will take for the United States and large enterprises to win the AI efficiency race. Jason Williamson, welcome to AI Realized.
Yeah, thanks for having me. This is great.
We're really pleased to have you, and we really enjoyed your remarks at AI Realized Summit. So we're looking to expand on what we learned from you there. As our audience is enterprise executives that are deploying AI, and the infrastructure that they use is obviously a topic that is very near and dear to their heart. For those enterprise AI leaders listening, how do you explain what MythWorks is building?
Sure. I think it's a bit of a seismic shift because we seem to have been conditioned pretty regularly is in this, and you talked about it in your introduction, in this idea of more GPUs, more power, more memory, all of those things so that we can have better LLMs to, I guess we would say, hallucinate less, which is great. This is not, and I'll be very clear, this is not a one or the other kind of scenario. We think we are a yes and when it comes to LLMs. And we'll get into this in a minute, but we're building expert systems in very domain specific areas at a fraction of the footprint. So going back to your original question, we'd have to look at what executives are ending up buying, right? They're not going to buy a full ChatGPT system because it's billions and billions of parameters. But if they need to run things in their own environment, they're going to have to invest in H100s or very expensive GPUs, or burn tens of thousands or hundreds of thousands of dollars a month, even on the hyperscalers, to even use 7 billion parameter models, which is what we see in the industry. That's the go-to. And so what we're trying to do is help other folks understand that if we look towards, let's say, look towards the brain, look towards creation, like how do we think and how do we learn? It's not in the way that an LLM goes. And so when you think about neuromorphic computing or neuroplasticity, we didn't invent it. We're not coming out saying, hey, we came up with this stuff. But what we're saying is that we're probably one of the first or early folks to operationalize this. And the idea here is how do you and I learn? You and I don't read a book, and before we sit down and read that book, plug something into our ears so that we can accommodate for the increased amount of data that we have to retain, or we don't have to create more energy in addition to what you already consume, right? Your brain is optimized to create neural paths to learn new things under a very constrained environment, yet it seems to still do that. And so that's essentially what we're doing. So we use techniques like, for example, like pruning. In our models, if a particular solution or solver isn't accessed very often, we prune it. Like, that's probably not any good. We're going to just clip that off. That's what you do when you sleep. When you sleep, you prune information that's not really used correctly or not that often. I don't mean forgetting things, but it's a way of being efficient. I'm probably jumping in a little deep on the technical side, faster than you want, but the short answer, or the long answer longer, is we try to mimic a resource constraint environment that we see in nature, which is the brain, not just in humans, but in all things, so that we can achieve a high level of accuracy. And the way that we do that, we can pull that through a little bit later, but the upshot is really low energy consumption. And because we're not doing a probabilistic prediction of words, we don't hallucinate. We either get the answer right and we verify it, or we get it, or we say that's not solvable with the way we're doing it, which is a contrast to what we see in an LLM. You either get it right a good chunk of the time, 80% of the time, or it's beautifully wrong. And you often don't know how to verify it. You can't verify it. Yeah, it's almost difficult to do that. So we're fully transparent, fully verifiable, and we're either always 100% right, or we just aren't, we don't have an answer.
Okay.
That's a lot. I know.
That fits many, but it fits many use cases, right? There are many cases where we would rather just have no answer than to have a possibly wrong answer, for sure.
Engineering, physics, construction, math, all those things, right?
Absolutely. Absolutely. I think it also brings to mind some other models that we've had some exposure to in our community, like neurosymbolic AIs. How is it different? How's a neuromorphing model different than a neurosymbolic?
Well, it's very similar. So we're using neurosymbolic ideas inside of that. We're just assembling these pieces in ways that take that idea and put it into action. We also use some quantum inspired math for some of the quantification of this as well. So again, we're pulling from nature to be able to figure out how to get these things done. So
Quantum inspired nap. I love that. Is this, say more about that?
yeah, so we're not doing the idea obviously we're not doing quantum computing, so we have quantum computers, but we use tensors that borrow ideas from many-bodied physics. So like annealing would be a term that our MythWorks would do that. But we execute that on classical hardware. Anyway, I don't want
Would satisfiability be part of what you would be doing?
it would be as it pertains to verifying. And that's the thing that we do is like we do verifier first. And so we have to make sure that the equations balance, that units are consistent, simulators hit their targets. So we're not trying to find the answer in a probabilistic way and then saying, hey, what do you think of this? We verify everything first and then go on top of that. And so the important part of that too is that the neuromorphic, or the plasticity part, is that we solve these, a lot of graph math, in small event driven ways where you have this like reward modulation that's very similar to dopamine hits. So like when you and I do something, your body rewards it, but ooh, okay, that's good. I'm going to go do that again. And so we do it very similar way. So the larger system is learning on a bunch of smaller systems that are firing based on I'll call it a virtual dopamine hit, which rewards on correctness and low energy budgets. And yeah.
So is it one model, Jason, or is it a system of things working together? Maybe models and other.
We have a mixture of solvers. So a decent corollary would be in the LLM space that we see, like MOEs, mixture, where you have a mixture of experts. So that's probably a decent corollary to that. You've probably seen those MOs that come out from different LLMs out there.
Okay, now let me ask a more basic question.
Yeah.
If I were looking to use this, can I go to a hosting company or go to your company, purchase it, download it, and run it? Or is there's more to it than that?
There's really not more to it. And so that's the kind of the exciting part, is that we are about to launch a private preview at the beginning of first quarter 2026. So as we just landed our seed round a month ago, we've been quiet for a while doing all of our things in stealth. So we're very excited about that. And that's all pointing towards a private preview in January. we'll open it up for people to invite, give us their use cases, and we'll pick who we think is a good candidate. And then we'll run that for them for a while and then GA Q2. But the short answer is yes, you would be able to run that in a mixture of on-prem or in a public cloud environment or on our own hosted environment. So we're talking with lots of different chip manufacturers and cloud providers, and even some that are looking to compete with the big hyperscalers, because we can actually, so it's a very interesting business problem now. Everybody's like pounding, I need H100s, or I need 200s, and we got to make them as fast as we can. And what happens is you've got all these other GPUs that were in fashion like 2 years ago that can't crunch what they need to crunch. So you got to cobble a bunch of them together. We're like, well, we love those. We love the small ones. So I believe we're going to be stumbling into helping some of the larger companies who've made big investments on GPUs that aren't useful anymore. We think they're useful because.
So what I reasonably intuit from that the cost of running your model is lower, but also the cost that we pay you is lower.
Fraction. You think, you could spend these folks, think industry, a car manufacturer, a chemical manufacturer, they're spending upwards of millions of dollars a year on training their models. They're racks when you think about it, right? They'll get a domain specific model, which is great, but it doesn't mean anything to them unless they put their own special, secret sauce in there. You got to train that up, and then then you have to put on an inference engine. So that's another thing. So that's where we really are being valuable, is that you're dropping this inference on low energy chips. And so this also is good because, and you hinted at this at the beginning, because I'm a really big believer in what I call Pax Americana for the idea of influence of AI, is that if our country is going to be a dominant and influencer in this space, which I think we should be, is that we've got an energy issue, we've got a data center issue. If you drive through Northern Virginia or Texas, you can see them going up everywhere, which is great, but they're months and sometimes multiple years away. And something's got to fuel that, right? It's what's really good about this problem is it appeals to both sides of the aisle, because you're energy constrained. So we either got to go find it, or renewal's not going to power that stuff. And are we going to find enough? And can we be independent? And there's a third rail, which is why we don't need so much energy to go do that. We can do it now at a lower energy. So we're not saying replace these things. We're just saying while that ship has absolutely sailed, we can't think it's a binary answer.
It's a little disingenuous to think that one size fits all in this or in any. So the idea that there is a fit for this technology that your company is bringing to market that runs on these older or slower processors, that there's a fit for that. Let's talk about that fit. Is it in things like, as you're talking about, say, automotive and so forth? I'm thinking this is more ideal for places where compute constraint is natural to the use case, like robotics or.
Sure.
Okay, so can you talk?
Sure. No, I think let me tie a bow on the previous one. It's absolutely a use case for people who don't want to spend millions of dollars when they don't have to. Like, why would you? So that is absolutely use case. I'm an engineering firm. I'm a car manufacturer. I'm a chemical company. I'm a law firm, all those things. Then the second, which is what you just described, which is absolutely a beautiful case, which is that edge case for us. You are a robotics company, or you're having to make decisions on a car. I have an EV car that has to make decisions about turning, and it's a speed bump. And I just got an upgrade for like trash in the road. And those inference things have to run on GPUs in that vehicle. What if we didn't have to do that? You can make smart vehicles more accessible to people who maybe can't drop that kind of money on a vehicle. In the defense space, the warfighter needs to be able to make decisions very quickly on the edge.
That helmet can only hold so much.
I've looked at interesting technologies with like mini data centers. Yeah. But the issue is like power. Like, how do you keep that going? And where's the data? And what happens when it, shrapnel hits it? So we can do that too. And it's important to also think about like energy signatures. That's a really big deal for technical operations. You can't be running around emitting a bunch of EM pulses or communicating with the cloud.
Heat, just something as simple as the heat dissipation.
All those things.
Yeah, sure. Also, I'm thinking about satellites. These are all places where you have constrained compute and high value to having AI. So I think that's very cool. So I like that you have three spaces that I'm hearing. One space is where you need to do things that are more deterministic, where science,
Yes,
math, etc.
correct.
Another area is where you are constrained in access to GPUs or budget for compute.
Right.
And the third is where you have compute constrained and you have high value applications.
Right. Right.
Is that a correct assumption?
You've hit that exactly on the head. So
All
I
right.
think those are very large areas that we're focused on, and I think is super transformative.
It is. It definitely is. And I think we're going to see more and more of this, Jason. I think we're going to see other types of models. I think we're going to see other types of energy profiles, sizes. One of the things John Sfiokla, who spoke at Summit as well, talked about is mobile is a coming, right? We are going to have the AI in our mobile phones, and that is going to change how we use our mobile phones and where we use our mobile phones. And obviously, the size of a model you can put in a car is different than the size of the model you can put in a phone. It seems, I don't know if your models can go that small, but
Absolutely, they can.
okay, there you go. Maybe this is an answer to the phone conundrum as well. So bringing this down to the executives who are listening, if you were sitting in the CIO or CAIO, we don't have a whole lot of those, but you're sitting in their chair at a Fortune 500 company. So I find it really helpful to go to the biggest of the big because for our audience, even though most of our audience is not in that particular segment, because they have every degree of complexity. They're global, they're multi-layer organizations, they have many lines of business, they're in multiple verticals, and they're driven by access to capital. So these parameters make it useful for that reason. That's why I'm modeling it there. So if you were a CIO of a Fortune 500 company and you want to stay ahead and contribute to keeping your company competitive in an America-friendly way, what are 2 or 3 non-obvious decisions you would want to make?
I think this sounds this sounds obvious, but is actually quite non-obvious. I think CIOs are really focused today on, we got into this business, we as technologists got into this business to like do cool things and be cutting edge. And often once someone reaches the level of the CIO, their life is just, let me keep the lights on and make sure no one calls me. And they often find themselves not in the innovator seat. I would argue that most CIOs are not the ones driving technology innovations within their company. They're reacting to what marketing needs and this needs and that needs, right? Look at the emergence of the public cloud was got to IT because a marketing person slapped down a credit card and bought a bunch of AWS because there's an application they needed that they weren't getting internally. And now the company's forced to realize, I got to go public cloud. So I think the non-obvious thing is for a CIO to carve out a chunk of their time and embrace this notion of AI and understand how that's going to fit within their organization. And I talk about this at the summit too, is understanding what your maturity model is and like understanding where you are within your organization. So step one is like embrace innovation. I know that sounds like all CIOs do that. I would argue most do not. I would say embrace that don't be afraid of it, embrace it. And then step two would be understand where your company is on the maturity model of AI adoption. You could be at level 0, you could be at level 5. You're probably not at 5, and it's understanding like, how do I get out of this like experimentation phase and understanding, just like we did with virtualization, just like we did with cloud, just like every technology. This was the argument I made during the summit, is that AI adoption's no different than when we went off the mainframe and we went to distributed, we went to virtualization. Like there has to be an ROI on there. And so if you can get really good at articulating where the line of sight to revenue is going to be for the organization, you can start not just being a cost center reactionary, and instead be able to provide like, ways for the company to move forward. Because at the end of the day, your business only is profitable with 2 levers. You only get 2 levers, lower cost or increased revenue. And AI has a chance to do both of those. So as a CIO, you need to start like re-engaging the language of finance for the purpose of driving EBITDA at your company. And AI can definitely do that, but being able to put guardrails and wrap words around where you are in maturity and be able to get that along is really good. And one of the reasons why we love what we do at MythWorks with the transparency is that you can often get through the very difficult compliance hurdles, because we always see that blocker. And as soon as you invite legal in the room, everything stops. And in this world, it's especially true because there's a lot of FUD in this space. And running ahead of that is very important. So with the way we do these things, we can't hallucinate. We're not doing probabilistic predictions on language. We solve things or we don't, and here's how it happened, and it's transparent. So being able to adopt technologies and running ahead of compliance is going to help you get there. And then understanding, the last thing I'll say on that is understanding how to articulate what that risk looks like. Because risk is just a probability of something going bad and a cost associated to it. And so if you can figure out how to get through those humps, then you can start turning I just need to keep the lights on and not get fired, to like, we're going to move this company forward because of technology. And I would say I've seen that in a lot of companies that have transformed that. I'm an ex-Cap One guy. I was a part of the IPO way back in the day where it was a little regional bank in Virginia and became a large credit card issuer. And technology and the role of the CIO there, in fact, the current CIO there is extremely influential in how a banking company moves forward with what they do technically. And looking at companies like that's a great case study and how we get these things done.
Jason, thinking about what you guys are doing at MythWorks with your different type of AI model, it strikes me that taking what you just said about the CIO becoming more of the innovation voice maps nicely to that, because they can say, look, this is a different AI model that is cheaper, lower energy, et cetera, and deterministic. So we lower our risk. So we've lowered all of the things that I'm responsible for. Now we're going to have the second part of this conversation, which I'd love for you to answer, which is how does the CIO go to the people in the organization who are currently using LLMs, who could be using this model, and explain to them why they should switch and what is the process of switching? How do I get onto your model and off of the one that I'm on today, or the ones, because they're all using ones.
Exactly. And I would argue that maybe you don't switch them all, because we're not a generalist where, if I'm going to ask, I'm doing an equation in math and I want to get a recipe for soup. We could absolutely build that. We're focused more on a mixture of solvers, but side note, inside of a year or two, we'll be in that level for sure. But I think it's the same way that you got them to adopt the ones in the first place. And so I like to see it as like a top down, bottom up approach at the same time. And so how did this happen at the company? They probably had a couple pilots. You had some cool kids with stickers on their laptops who had great haircuts. Who was like, oh, I'll go do it. And then you had some business sponsors that had, again, line of sight to revenue to understand, if this thing works, I get this out of it. And so I feel like it's the same way that they got the LLM to adopt before. But as I'm pretty sure I mentioned this on the panel from the summit, it's an OB issue as much as a technical issue. It's an organizational behavior issue otherwise, because the fact there's LLMs there, that's like the hardest part. Like just getting people over the hump that AI is like a good thing is probably the hardest battle. So if you can get them to go, hey, there's another way, let's go try this now, then you've already done the hard sell, is the organizational behavior side of the house.
Let me ask a naive question. Would I also be wise as this fictitious CIO to go find someone who has a use case that's deterministic by nature?
I feel like they all are. Like if you're at a bank, you're trying to figure out risk models. You're trying to do monetary pressure tests. You're trying to do algo trading. You're trying to asset reality. Those are all deterministic. If you're at a company that makes things and you got to do simulations on your engines, you've got to look at predictive analytics, prediction on your supply chain. I would say most of the models that are being executed today are deterministic models.
Meaning they're deterministic use cases, but the money.
Deterministic use. Thank you. Well, exactly. Look at that. You're correcting me. Yes, exactly.
Yeah.
Most of it is not like I need to create a new novel.
Yeah, fair enough. So let's step back even further for a minute. Where do you see AI transforming the enterprise in the next 2 years?
I think we're still going to probably engage in a bumpy, fuzzy front end phase for the next 2 years. There's going to be some disruption. As the more AI gets adopted, I think you'll find the more uncertainty that gets injected, meaning what does this do to my workforce? How do I re-engage them? Do I fire them all? So I think the enterprise is going to go through a little bit of a crisis of what do I do with this? I think there's still going to be cost pressures because as the price of compute does not decline and the cost of GPUs and the accessibility continues to be more difficult, there's going to be price pressure to make sure that there's a return on investment much quicker than we're out of experimentation. Yes, we get it. It does cool stuff. You need to show it to me now. And I've just been going through some infrastructure purchases, and it's really interesting out there right now. Price pressure is a pretty real thing in the infrastructure space right now. So I think in the enterprises they adopt, we're going to see that. And then we'll see some uncertainty. I think it's a strong, that's not a headwind for us. That's a tailwind. So as the price pressures continue and availability and accessibility continues, because of lack of big data centers, that's good for me. Give me the small stuff. I was just talking to somebody just the other day. I was in the Marine Corps, and we pride ourselves on having less and being ill-funded. It's not the right word, but like under-resourced, less gear.
Minimum water, not maximum water.
That's right. I want least. And so for us, it's come on, let's go. We don't need it to get it going. So the future is going to be those things which for a select few of us in this space that are delivering technologies in a way that are resource constraint is an upside for us to take some of that market share just from a selfish perspective, but it's also good for the customer. And so I think that's our future.
What resources do you recommend to listeners who want to learn more about the work that you're doing and about MythWorks and your technology?
Yeah. So I think you can go look and see what Intel's been doing. There are some chip manufacturers that are like Intel is doing this, Cerebras is doing small compute on the edge. I think go just take a look and see what's happening there. There's a lot's being done in the academic space. There's a couple companies a couple like us that are out there doing this for real. So I would say start at Intel and go take a look at what they're doing in neuromorphic, and then just let your curiosity keep taking you away there.
If our listeners remember just one thing from our conversation today, what would you like it to be and why?
I think the one thing that I would like people to understand and take away is the way that we move. If you want to do things differently, if you want to get different results, you have to do things differently. Right. And so right now, to do things differently isn't more power, more chips, more data centers. It is do more with less. And so that's what I want people to think about. Like, how can you do more with less? So if everyone is running that way, I think maybe Sony needs to run the other way. And last, I'm just remember something that Safra Katz said. Safra was now the chairman of Oracle. She was CEO there for a really long time. And you mentioned this earlier. I ran startups and venture and research for them for a while. And Safra said, if everyone is telling you you're crazy, you might be onto something. And so I think that's what I love people to take away, like when they're engaged in this AI space. If they're telling you you're crazy because everyone's running that way, then you might be onto something, because we certainly think that's true.
Okay, gotcha. Your background is so diverse and interesting, Jason. You've been a leader you in mission-based organizations like your human trafficking and your faith-based work. You've been involved as your military leader. You've been a corporate enterprise leader. You're leading a startup at this point. I mean, if I've left anything out, please, I don't mean to diminish. It's isn't popping to mind.
Yeah.
As a leader in this era, in the AI era,
Yes.
what is the skill or the leadership capability that you find most valuable in the AI AI era?
The AI era is it's connection with people. I just recently I'm not going to tell you like, be good at prompt engineering and be good. Like, it's the human connection. One of the organizations that I'm involved with in the startup portfolio, we just had a offsite in Charlottesville, Virginia, which is where I live, just south of Washington. So we're spoiled here being in Appalachians. And it was a chance to all these people work remotely. A couple of them are in together, but that's just the way it is. And being able to have like human connection to look at vision and look and why is the vision there, and to understand things about each other and understand what motivates them and what dismotivates them, and getting on the same, like that stuff is magic and it's gold. And as we move into this AI space, we're continuing to get pulled apart as people and as humans. We saw that accelerated in COVID. And so we have to, again, we got to run against the grain a little bit and get back into connective tissue, because that is probably the single most thing a leader can do, is really understanding the humans that are involved there, not just like your DevOps and your technology, and make sure you're hiring the smartest people. Like all those things are important, but it always comes down to the organizational behavior aspect of that, and the culture that you build, and the ability to navigate like adversity together and all those kinds of things. Absolutely. That is, as a leader, hands down, it's all about the people. That sounds kind of cliche, but it's true.
It sounds like you feel like it's even more true in this era than in previous roles you've been in, because you're calling it out as because obviously that was important in other roles.
Always, yeah. In the military, in the mission field, and you're like going to like rescue kids and all that. Like people are important, but we're in a culture that is constantly driving us apart. We're in a culture that's constantly telling us the people that don't agree with you are evil, and we're constantly in a culture that is it. Entropy is a thing. It's real, and it's real in humans. And so we have to go against that. And I could we'd have a whole session on that. So.
We could indeed. And you're a fascinating person and bring a lot of interesting insights to the party. So I hope we do have you back again soon. But for now, let me say thank you, Jason Williamson, CEO of MythWorks, for joining me today on AI Realized.
Thank you. Grateful for the time.